Our next section is on the order of operations. The order of operations is important because if you have any kind of mathematical equation or expression that has more than one operation that you need to perform, we all have to agree on a certain order that the operations be performed in, or we can come up with a very different answer. So it's a valuable means of communicating exactly what it means for someone else to do and the order that they need to do it in to arrive at the same conclusion that we meant for them to. The order is very simply parentheses, exponents, multiplication and division, and addition and subtraction. It's simplified to that, but we need to make sure that we understand what each one of those steps means. Parentheses means to perform any operations inside a grouping symbol. Inside the grouping symbol. Grouping symbols, most people understand what grouping symbols are, although some of them are a little surprising. There are, of course, your parentheses, brackets, which are just square-looking parentheses, braces, the curly Q things that nobody can draw. But another symbol for grouping is a radical sign, like a square root. You do whatever underneath the square root as much as possible before moving outside of it. And fraction bars. Fraction bars are a grouping symbol because they group the numerator with the numerator and the denominator with the denominator. And if there's any operations performed in either one of those, you do that first before you consider the fraction. Exponents. You know what exponents are. If you have a number and then you've got the little floaty number up in the air, that's the exponent. You do those second. Or you do any roots, like if you have a square root. Up above, if we have more than one operation below the square root, we did that first. Then the second thing would be to take the square root of that number. We won't really get to those until we get to the next chapter. Multiplication and division, which you have to understand is all multiplication does not become before all division. When you read from left to right. That's the same way you read math. So if there is multiplication and division in a problem, you do it as you come to it from left to right, even if the division comes before a multiplication sign. Same thing with addition and subtraction. If you have a string of add and subtract, it doesn't mean do all your addition first, then come back and do all your subtraction. You will do those two operations with equal importance as you come to them from left to right. Now, you can do these by hand, but again, we have technology, and we're not really worried that much about the arithmetic so much as we are being able to communicate what it is that we want someone else to do, in this case, our calculator. Our calculator is programmed to perform the order of operations if we tell it everything correctly. Now in the first problem, I have a multiplication here in the middle. I don't know if I need to do that first or if I forgot. Order of operations is on the other page, but my calculator will know. But if I have parentheses in the problem, I need to not be lazy. I need to type my parentheses in a calculator if I've got that kind of device. So, negative 12 plus 2 in parentheses, negative 4 minus 10. Nowadays, your calculator knows if I don't put a symbol in there what that means. I should be able to just hit equals or enter, and I should come up with negative 30. Number 2, again, you could put a times symbol in there. An extra symbol won't matter, but type in the problem exactly the way it looks. The calculator understands the order of operations. It will do what you tell it to do. Every time you open a parenthesis, you have to make sure you close it. If you don't do that, you might be miscommunicating what you mean for the calculator to do. So you type, let's see, I'm trying to type and talk at the same time. You type, you get your answers, make sure they match mine. If they don't, you need to take a good look at your technology, and you need to take a good look at what you're doing and figure out how to appropriately use your technology to get the correct answer. Remember, we're past the arithmetic kind of class. What we want to be able to do is to use our device effectively to get these answers so that this is not where we get stuck in a problem. Fractions in particular can pose a problem with technology because the fraction bar itself is a grouping symbol. It's one that we take for granted. When I write a fraction 2/3 on a piece of paper, I can keep the numerator like totally separate from the denominator. I could tell a top from a bottom. But if I'm using some kind of device where I'm typing in line, the 2 and the 3 it is on the same line. It's just got a slash between it. Now what if I add some type of operation to this, where I say 2 plus 1 over 5 minus 2. When I look at that the way it's written here, I would clearly do the math on top, then do the math on the bottom, and reduce my fraction. If I were to type that into a calculator, it doesn't look the same. 2 plus 1 over 5 minus 2, that's not what I see when I read this. That looks like it says 2 plus 1/5 minus 2. 2 plus 1/5 minus 2 is not going to equal 1. And if I want to communicate this, I need to make sure my numerator is grouped with my numerator. My denominator is grouped with my denominator. Now these two statements are equivalent. So you have to be careful with fractions in order of operations. Now, to work some of these problems, sometimes we can work them just the way they look. Otherwise, we're going to have to put in some extra parentheses. So this first one's a good illustration of what I was just talking about. If I'm going to put this into a straight line kind of device, if I want it to read the numerator as the whole 17 plus 13, and I want it to read the denominator as both -2 times 5, when I type it into my calculator, I'm going to have to do so with an extra set of parentheses for the numerator and an extra set of parentheses for the denominator. And I should end up with -3. Now on number 7, it's a good idea whenever I type a fraction to go ahead and enclose it in parentheses. In this case, especially with division, you want to make sure that the calculator knows exactly what it is that you're talking about. So I want to type in the 2/3 in parentheses and then the division sign in between then my negative 1/6 plus 5. Now I should probably ask the calculator to give me that answer as a fraction, but this turns out to be positive 1, so that doesn't matter. On number 8, again, I should enclose all my fractions within parentheses just to be on the safe side. Some operations are fine without using the parentheses. Some, if I don't have the parentheses, the calculator will read what I've typed totally wrong. Therefore, the extra parentheses never hurt, so why not use them? I type this in and I get 5/9. So if you'd like, why don't you try the last two on your own, see how that goes, and then after you finish them, turn this recording back on and see if you've gotten them correct. If I want to type number 9 in and I want to enclose my fractions in parentheses, I need to use one set of parentheses for the ones that are already there. Now if I want to put 1/2 in parentheses, I need to open and close a whole nother set with the plus sign in the middle, and then put 1/5 in a whole nother set, which means I'm going to have double parentheses at the beginning and double at the end. If I didn't do that, if I just put 1/2 in parentheses and 1/5 in parentheses, then the only thing that's getting multiplied by 4 is the 1/2. I need the extra set to make sure I do what's inside these parentheses first. Now, if I do that correctly, and I ask for my answer to be given to me in fractional notation, then I'll get an answer of 34/5. Now, if I wanted to change that to a mixed number, I could, because I learned how to do that in the last chapter, but I don't really have to. On the last one, if I enclose each little fraction in parentheses to be safe, and again I ask for my answer to be given to me in fractional notation, I'll end up with an answer of 1/6.